So next question is question number 2. Differentiate the following expression with respect to the variable involved. The first part is to differentiate x square secant 4x. We'll start our solution. Let y is equal to x square secant 4x. So just given a name to this function or this expression to y. So y is equal to x square secant 4x. As y is the function of x, so we have to calculate a change with respect to x. So now applying differentiation with respect to x, as I mentioned here, we have to differentiate with variable involved. So this means that whichever the variable appear, we have to calculate the change or differentiate with respect to that particular variable. And here the variable is x. Now left hand side will become dy by dx, and derivative will apply on right hand side, that is actually x square secant 4x. So by applying differentiation, actually here we will use a product rule, as there are two functions, one is x square and other is secant 4x. So when we apply derivative, x square will be as it is and derivative will apply on second function, which is secant 4x, and then secant 4x as it is and derivative will apply on x square. Now this x square will be as it is, and when we apply differentiation on secant 4x, as the formula of secant 4x was derivative of secant x, which is actually secant x into tan x. So this is basic formula for differentiation of secant x. So here we have secant 4x angle, which is not x but multiple of x. So again using a differentiation technique, then that is differentiation will apply on this basic function, which is secant, and derivative of secant is secant into tangent. And whenever we have an angle which is also a function, like if we generalize this result as we have angle which is actually multiple of x or itself a function, then derivative will apply in such a way, derivative of secant will be secant into tangent. So secant f of x tan f of x, and then derivative will also apply on angle separately. So this is actually the process of differentiation of trigonometric function with an angle which is actually consisting of a function itself. So that will become secant 4x, derivative of secant 4x will be secant 4x tangent 4x, and then derivative will apply on 4x, which is actually derivative of 4x will become 4. So now onwards, or in the next questions, we will apply the same technique whenever we have a trigonometric function with an angle which is consisting of a function. So by applying derivative, we will first apply differentiation on trigonometric function and then derivative will apply on angle. So finally we have derivative of secant 4x will be secant 4x tangent 4x by using this basic result, and then derivative will apply on angle, which is explained from here. Now in the next part, secant 4x will be as it is and derivative will apply on x square, which is 2x. Now just simplify this result. We have 2x secant 4x as a common factor, then the remaining part will become 1 plus 2x tan 4x. Actually 2x secant x will be common from here, then that will become 1. So here we have 1 plus, then by taking 2x and secant 4x common from here, that will become 2x tan 4x. So this is actually a complete differentiation of the given function, which is x square secant 4x. The next question is to differentiate tan cube theta secant square theta. Here the variable involved is theta. So we have to calculate a change or differentiation with respect to theta. Solution: let y is equal to tan cube theta into secant square theta. Remember, the variable involved here is theta, so differentiation will have to apply with respect to theta here. So differentiate with respect to theta, dy by d theta, and on right hand side d by d theta on applying tan cube theta secant square theta. Again, we have to apply a product rule because this function is consisting of two functions which are multiplied with each other. So by using product rule, this will become tan cube theta will be as it is and derivative will apply on secant square theta, plus secant square theta will be as it is and derivative will apply on tan cube theta. So now derivative will apply in a way like tan cube theta will be as it is and derivative of secant square theta. Here first power rule will apply, as this is a function containing a power. So when we apply differentiation on this function, that will become power, which is 2 secant power 2 minus 1, and then derivative will apply on secant theta, which will become secant into tangent, plus secant square theta will be as it is. Again power rule will apply on here, 3 tan 3 minus 1, which is 2, and then derivative will apply on tan theta, which is actually secant square theta. This is a derivative of secant theta, which already discussed in first part, and this is actually derivative of tan theta, like d by d theta of tan theta, that is actually secant square theta. So this is actually use of differentiation of derivative of tan theta. Now we have tan square theta secant square theta as a common factor from whole this expression, or from both of these two terms. The remaining part will become 2 tan square theta plus 3 this secant square theta, and this tan square theta is going to be a common factor, so the remaining thing will be this 3 and this secant square theta, which is actually our complete differentiation of the given question. The next part is differentiate sine 2 theta minus cos 3 theta whole square containing a power 2. Solution: let y is equal to sine 2 theta minus cos 3 theta square. Differentiation will apply with respect to theta, as the variable involved here is theta. So differentiate with respect to theta, dy by d theta, and on right hand side d by d theta will apply on this part, sine 2 theta minus cos 3 theta whole square. So when we will apply differentiation, first we use power rule. So 2 sine 2 theta minus cos 3 theta 2 minus 1, which is actually n function, and then n minus 1, and then derivative will apply on this inner function, which is sine 2 theta minus cos 3 theta. So the next thing will become 2 sine 2 theta minus cos 3 theta, 2 minus 1 will become 1, and derivative of sine 2 theta, as we discussed in our first part, derivative will apply on sine, which will become cos. The angle is 2 theta, that is remain same 2 theta, and then derivative will apply on this angle 2 theta, which is 2. Differentiation of 2 theta will be 2, plus derivative of cos theta is actually minus sine theta. So this minus and minus will become plus, and derivative of cos will become sine, angle is 3 theta, and then derivative will apply on this angle 3 theta, which is actually 3. So this is actually direct result of sine 2 theta, which is 2 cos 2 theta, plus derivative of cos 3 theta will become 3 sine 3 theta. And the next part is to differentiate cos with an angle square root x plus square root sine x. Important question is actually let y is equal to cos square root x plus sine x square root. Differentiate with respect to theta, but that here variable involved is x, so actually this one is differentiate with respect to x, actually composing mistake actually. So differentiate with respect to x, because the variable involved here is x. So d by dx will apply on left hand side, that will become dy by dx, and then derivative will apply on right hand side, as this is consisting of two terms, cos square root x plus sin x square root. Derivative will apply separately on both of these two terms, derivative of cos square root x plus derivative of sin x square root. Derivative of cos will become minus sine with angle square root x, and then derivative will apply on angle, which is square root x, plus this is actually a function containing a power 1 by 2. So power rule will apply 1 by 2 function and then 1 by 2 minus 1, which is actually minus 1 by 2, and then derivative will apply on this inner function sin x, as derivative of sin x is cos of x. Now the next part or next step will become minus sine square root x, and derivative of under root x or square root of x will become 1 by 2 square root of x. A basic formula of square root of x, derivative of square root of x will become 1 by 2 square root of x plus cos x. This is sin x with power minus 1 by 2 will be shifted to denominator and will become a positive power. So the whole thing will become 2 square root sin of x. A complete differentiation of our required question is 1 by 2 is a common factor, and that will become minus sine square root of x divided by square root of x, plus this 2 is a common factor, so the remaining thing will become cos of x divided by square root of sin x.